Hello everybody, welcome to my channel. Today we have a very good problem for you guys called the next greater element 2. So this is a very good problem, and it's actually the second problem, right? The sequel to the first one that we did. It was called next greater element 1, right? So I highly suggest you guys go check it out. It's gonna make a lot more sense to you guys once you guys look at this problem first and then come back to this one, right? So let's get started, man. So it says given a circular integer array nums, right? Okay, find the next greater element. So he says to return the next greater number for every element in nums. Okay. So he says the next greater number of a number x, right, is the first greater number to its traversing order next in the array, right? Which means you could search circularly to find its next greater number. If it does not exist, right, return -1 for this number. Okay. Pretty simple problem statement, right? So we're given this nums array, and our job, right, is to find the next greater element for each of those numbers, right? Okay, and it says that we could search in a circular manner, right? It's not, only that we search, do a linear loop, traversing from left to right, right? We can also wrap around the array, right, and try to find it at any point, right? So for example, this one, right, there's nothing to its right, but if you search circularly, right, we go start at the beginning again, right, could find 2 to be its next greater element, right? Okay, that's kind of what they're saying here, right? So for 1, it's easy, right? We loop through, we loop through, we find 2, that's the next greater element. For 2, we look, there's nothing there, we put -1. For 1, there's nothing, we go loop again, and then we find that there's a 2 that exists, right? Okay, that's what they're saying here. Okay. This one, it's kind of a similar thing, right? For 1, its next greater element is 2, right? Even though 3 exists, right? But that's not its next greater, right? We want the first greater element, right? Searching, from left to right, right? Okay. So 2, it's its next greater element. We put 2 there. Okay, then for 2, its next greater element is 3. For 3, its next greater is 4, right? For 4, we find nothing, right? Even if we go there and then we go search again in the beginning, right? There's nothing there. In the whole array, we put -1. And then for 3, right? Its next greater, we had to do a circular search, right? And then find 4 here. Okay. Yeah, so I put 4. So that's kind of how they derive, those output results, right? It's kind of the whole gist of things. So how can we go ahead and solve this, guys, right? So the most straightforward way, which we normally like to start off with, right, is the let's not be clever, right? For each number, we do a for loop that scans the whole array. Okay. Okay. So that scans the whole array essentially, right? So for 1, we would search the rest of the array, find a greater number, put it there. Okay. And then for 2, starting from 2 onwards, check the array, right? We find nothing, we put -1. For 1, right, we search the rest of the array. But you see that, that's not gonna cut it, right? So we have to be a little bit more, because how do I know there's a 2 here? Okay. Because 1, right, if we're doing a left to right, that inner for loop, right, so rooted at that, we need to find a way to also go there, right? So what we can do to handle those cases, right, we do so we create, right, we simulate, right? So what I'm doing here is simulating, right, because we need to handle the case where we're searching circularly, which is the important part here. Okay, because what I was saying, right, is 2 for loops, right? Starting, so the first for loop scans, right, and for each of those elements, right, we search from that element onwards onto the rest of the array. Okay, so now how do we handle the case where for 1, right, we search the rest of the array, got nothing, right? We need to make sure that we start from the, we wrapped around the array, right, and then we search again, because there might be an answer going from that wrap circularly, like for 1, for example, right? And we search again circularly, we're able to find 2 as the result. Okay, so we need to handle that case, right? So for those cases, right, to simulate that searching circularly thing, right, we can pretty much double the size of the array, right? So we have 1, 2, 1, right? We just make sure that it's a 1 to 1, right? We double it, right? So we're not really gonna double it like for real. We're only gonna do the modulus, right? To kind of, you know, keep it within the range, right? So let's say we go from index 0, index 1, index 2, right? And then, you know, to simulate that we want to go to the next beginning of the array again, right? So this would be index 3, right? But, right? So you might be saying, oh, are we going to get index out of bounds? To keep it within the range, right? We're going to do the modulus of n, because that's a typical way to keep the ranges within those numbers within the bounds, right? So the size of the array right here is 3, right? So at index 3, we would have 3 mod 3 is equal to 0, right? Equal to 0. And that's how we would, you know, keep that within bounds, right? So it would search 0, and then it would do the same thing for index 4, right? Which is, right? And then 4 mod 3 is 1, right? So we're referencing this particular index, right? And we keep doing that, right? So, and then we go to index 5, right? And then now the thing would be 2, right? We'll be referencing this one, okay? So that's kind of how we will like do the simulation of, like, you know, searching in a circular manner, right? By using the modulus thing to keep it within the index range, right? We could reference like the particular index that we want, right? So you can kind of visualize the index, right? So this is the original array, right? And then we extend it, right? The whole array again, so that we can search, can kind of like simulate the searching circular. This is a very popular way. Like this is a very, like, this is how we normally do it, like when we need to search in a circular array, right? You know, where the thing wraps around the array again, right? So that's kind of how the whole gist, right? So it will be kind of similar like that, right? We would do a for loop, right? For each element, search the whole circular array, right? And you can see that it wouldn't be too efficient, right? You know, that n squared would not be very good, okay? So you see, it won't be too efficient, because for each number, we need to search the whole thing, right? To see if there exists one, right? You know, so that's not very, very good, okay? So this is how it would work essentially. So the output results, just make sure that I can show you guys, right? The output result will be, so for 1, right? So initially everything will be -1, right? -1 is output results. You see that it's the size of the original size of the thing, right? I just went ahead and like, you know, visualize, so you guys could visualize it, and I expanded the array, right? So okay, so now for 1, we just look, we find the first one, right? We got lucky, it was right next to us, right? And then we see 2, search the rest, right? Goes to 1, then continues to tries to find, right? Next where it doesn't find it, okay? So it searches the whole thing, right? Okay, ends up with nothing, so we get -1, and then from this one, and we search the whole thing again, guys, right? And it finds 1, oh, it finds 2, yep, there it is. Then we go ahead and put the 2 there, and that's how we end up with those answers, right? To see double for loop, keeping it very, very, very simple, okay? So now, the next thing that we're gonna do, is so the time complexity is not very good here, right? You know, the double fold never cuts an interview for most problems, I would say, right? So now, how can we improve the time complexity? So the yellow problem, what we ended up doing was introducing the concept of a waiting area, right? So instead of, you know, trying to answer the question right away, right, we put our numbers, right, into some sort of a waiting area. So the waiting area, the numbers are just chilling there, right? So the thing was a stack, right? A stack here was kind of the monotonic stack technique. So it was monotonic stack because the sequence, right, we had a monotonically decreasing sequence, because we were trying to find the next greater element, right? And it was monotonically decreasing because the waiting area, right? Because let's say you have 2 numbers. Okay, we have 1 number in the stack, right? 1 number waiting in the area, right? And then we encounter another number at another iteration, right? We ask it a question. We're like, are you bigger than the current number that's in our stack? If you're not greater, then you go ahead and join the list, right? But if you're greater, you're able to kick it out, and you're the answer for the number that's waiting inside of the stack, right? Because that's kind of the whole thinking of it, right? Because, you know, we decided that we were going to choose to add the numbers as we go along and add future iterations if we end up finding, because we know the numbers we've seen in the past, right? And we know the current numbers that we're on, right? We don't know what can happen in the future, but we know those two things for sure. And that's why we're keeping track of the numbers that we've seen before. And at future iterations, if we encounter numbers that are greater than those numbers in our current list, right, we can kick them out and then use that the current number that we're on that we know for sure is greater than them, right, as the answer for those previous numbers that we've seen, right? And that's why if they're not greater, the current numbers, right, that we're on, or not greater than the number in the stack, right? So if we have two numbers, right, one's in the stack, we have a 4. Let's say we have 4 waiting in the stack, right? And then the current number that we're on is a 2, right? If that's the case, then the 2 can't kick it out, so it just goes ahead and joins the waiting area, right? And this number is also waiting for another number in the future that can help it to be resolved, essentially. It's kind of the whole thinking and the whole process of things here. Okay, so we put 4, and then we put 2, right? So this is just an example to help you visualize how it can be. So we have a stack, and then we go ahead and add the numbers as we go along, right? And then at future iterations, if we see end up finding numbers that are bigger, then we use those numbers that are bigger as the answer for that particular number, right, that's in our stack. Okay, so for 1, it puts itself in the stack, goes on to the next iteration. We go to 2. 2 is bigger than the current one, right? So it can use itself as an answer for this one, right? Then it puts 2, and then we can kick it out because it has been resolved, right? And then we see 2, right? 2 greater. 2 goes on to the next one, right? Is 1 greater than 2? Yes, it is, right? Then we put, no, it's not. We put 1 in there. Okay. Now, so yeah, 2, 1 is not greater, so it goes ahead and joins the waiting area, essentially. Okay. So now what's next for us to do now is to continue, right? So we add 1, so it's not greater, right? So now this is the duplicate portion of the array, right? You know, and remember with that, we're not going to really like double the array, right? We're going to use the modulus thing to keep the numbers within the range, like we've agreed on, right? So once we go on to index 3, because the linear loop that we're doing, right, goes up to index 2 times the length of the original array minus 1, right? It's kind of what we're going up to, right? For this particular case, the n is 3, so it's 2 times 3 is equal to index 5. So we go all the way up to index 5, right? And then we use the modulus thing to keep it within range, within this particular range of 0 to 1, 2, right? 0 to 2. All right, so we keep it within that range. Okay. So once we get to that portion, right, we don't add those numbers into the stack, right? We just use those numbers, the duplicate portion, right, as a way to help us answer our current, like the answers for the numbers currently waiting in our stack, right? And those are the numbers that we need an answer for. Okay. So once you get to index 3, right, we ask, cool. This number, is it bigger than the minimum number in our stack? Right? No, it's not bigger, right? It doesn't help at all. So it goes ahead and skips it. Then we go into this number. We're asking, is this number bigger than the number in our stack? It is, right? So that's the answer for 1, right? And that's how we end up adding 2, right? Has the answer here, okay? And then for 2, these get kicked out. Then we continue asking, is it greater than this one? No, it's not, right? So nothing happens. And then we go on to this last number. Is it bigger? No, it's not bigger, right? So this is how we end up with the final answer there, right? We do a linear loop, right? We handle those cases of the wraparound logic, right? You know, this is just to help you guys visualize it. Remember, it goes ahead, right? We just incrementing our index, and then we use the modulus thing to keep this within bounds, right? To reference those particular indices. Okay, so it's kind of the whole just the whole problem here. Okay, so the code will be even simpler once you guys get into it. Yeah, like I was saying, the code will be very simple. Let me zoom in so you guys can see everything. So the code will be as such, right? So we'll set that we'll be having a stack, guys, a stack to kind of help us in implementing the monotonic stack, right? Okay, so we have our stack. We're gonna initialize it. So now we're also be needing the result array, and it has to be a particular size, right? So let's capture the size of the array, right? Okay. So we want the output result to be of this size because we want it for every index. And then now what we're going to do is to do a linear loop, right? A linear loop to handle this case. So I starts at 0. I is less than what? N, right? But I told you guys we're going up to 2 times n, right? I plus plus. Okay. So that we handle the wraparound logic, right? So we're looping through n twice, right? Okay. That's kind of what I'm doing here. Now what's next for us is to start, pushing the index, right, for each number, right? We put the index in there. We don't put the actual number because there are duplicates in this particular problem, right? And the other problem we didn't push the index, push the actual number because they were unique, right? But since we have duplicates, right, the identifier for this problem is the index, right? That's why we're pushing the index in this one. Okay. So now what I'm doing here is to start, so as I'm pushing the numbers, right, the index of those numbers. So now the numbers in our stack, right, the numbers that are currently waiting now, right, we're going to start trying to resolve them, right, because we said that we'll be adding them into the waiting area. And if we end up finding numbers, right, at a later iteration that are bigger, then we use those numbers as answers for them, right? So now what we're going to do here, if the current number that I'm on, the current number, right, and we do mod n so that we keep it within range, right? Because when we get to index 3 for this particular example, right, if we were to just do I, because we're looping through 2 times n, right, we would get index out of bounds, right? It wouldn't be too good, right? So now we check if this number, right, is it bigger than the numbers that are currently waiting inside of our stack? And we have access to that by doing this, right? It's that peak, okay? It's bigger than the numbers that are currently waiting, right? And there's one important thing that we're going to do, right? The numbers that we're pushing into our stack, right? We're only going to push the original numbers, right? The first time around, right? When we wrap around again, we don't need to push them again, right? There's no need because we already, added them to our stack, right? And we don't need to add them to the waiting area again. It's the second time around, okay? So that's why I'm keeping it in balance here, okay? And I don't need to do mod n because I'm handling the case here, right? Because I'm only adding index from 0 to 2 here, right? This particular example, right? Okay, so I'm good. So I needed to do this for I because it's going to 2 times n. Okay, that's kind of what I'm doing. Okay, so now let's say, all right, so we've seen the case where the current number that I'm on is bigger than the minimum number currently waiting in the area, right? Then I could kick that number out because we're able to resolve it essentially. Okay, so pop is equal to the current number that I'm on right now, which is I mod n. Right? Need to handle that, okay? Yeah, and then it keeps doing that, guys. So it's as simple as that. And then at the end, we just return the result. Okay. Let's look at the code. So we have our stack and we have our output result, and we loop through with a linear loop, looping through it twice, right, up to 2 times n. I've explained why. And then we add the index of each number, right? And then at later iterations, if we find if we're on a number that's bigger than the number that's currently waiting, right, the numbers that are currently waiting, we go ahead and kick those numbers out and resolve them. And we add that in the answer for those numbers, right, is the current number that we're on, right? And we do modulus n to keep it within range. This is very important, right? You guys get that, okay? So one important thing to really finish it is to fill up the array with -1 first, right? Like I was doing in the walkthrough here, okay? So let's press run code, man. See if we pass these small test cases. Looks like we did. Let's press submit. All right, looks like we passed all the test cases, guys. If you guys really enjoyed this particular problem, you guys really enjoyed it, in the comment section. If you guys are new here, make sure to subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.